Hello and welcome to 10.3 Notes. Today we will use relationships of arcs and chords in a circle and applying properties of chords. Okay, so there will be a few theorems that you will be responsible for, and so I'm going to present those theorems to you and then show you some typical types of problems that you would get regarding each one of those theorems. Okay, so here we go. So the first theorem states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so you have, for example, this chord being congruent to this chord. Okay, and we know that because of the tick marks. So those two chords are congruent to each other. Therefore, arc AB, this arc, is going to be congruent with arc CD, this arc. Okay? All right, so typical kind of problem that you would get would be like this here. So please copy down this prompt, copy down the circle and with its labels, and please write down this prompt. If the measure of arc AB is equal to 110 degrees, find the measure of arc BC. Okay? And remember, as always, you are in total control of this presentation. If you want to fast forward, rewind, pause this at any time, you may do so. Please feel free to do so. But I am going to continue. Okay? So, if the measure of arc AB is 110 degrees, so this arc is 110 degrees, all right? Find the measure of this arc. Well, according to this theorem above here, okay, theorem 10.3, it says that if the two chords are congruent to each other, then the two arcs are congruent to each other. Well, these two chords are congruent to each other. Okay, they don't have tick marks, but they're both 10 inches long, so they must be congruent to each other. Therefore, the arc length, the degree measure rather of arc BC is also 110 degrees, right? If these two are congruent to each other, and this is 110 degrees, this must be 110 degrees as well. Okay? All right, and then moving right along, we have this next question. If the measure of arc AC is equal to 150 degrees, find the measure of arc AB. So now in this case, the measure of arc AC is 150 degrees. Okay, and we know that in a circle all the way around is 360 degrees. Okay, all the way around is 360 degrees. We know that this portion here is 150 degrees. So if we take 360 minus 150, we know that arc AB plus arc BC, the remainder of the circle, must be equal to 210 degrees, correct? But we also know that these two arcs are congruent to each other because these two chords are congruent to each other. So, therefore, 210 degrees is equal to 2 times x. If we call that value x, if we call this arc measure x, then this arc measure is x as well. Okay? So 210 degrees then is equal to this plus this, or 2x, right? X plus x is 2x. Okay, and then moving right along, divide both sides by 2, and you get x is equal to 105 degrees. So the measure of arc AB is 105 degrees. Okay? Next we have, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so let's examine that sentence here. If a diameter of a circle, well, is this a diameter? Is EG a diameter? Yes, it is, because it goes through the center of the circle, right? Any chord that goes through the center of a circle must be the diameter. So yes, this is the diameter. Is it perpendicular? Yes, it's perpendicular because it has this little perpendicular symbol. Okay, well then if it's a diameter and it's perpendicular to a chord, this chord, then it bisects the chord and its arc. So that means that HF is going to be congruent with HD. And also this arc FG is going to be congruent with arc DG. Okay? So they're all going to be congruent. Again, if this is a diameter and it meets the chord perpendicular. Okay? All right. So what kinds of problems might you get with this theorem, using this theorem? All right, problems like this. So please copy this down. Find the measure of the indicated arc. Remember, you can pause this presentation at any time you'd like, but I'm going to move on. Okay, find the measure of the indicated arc. So please copy down this circle with all the labels, and please write down this prompt, and these are the questions. What is the arc measure of CD, DE, and CE? Arc CE. Okay, so let's work on number 3, finding the arc measure of CD, which is 9x. Well, we know that this is a diameter, right, because it goes through the center of the circle, and it does meet this chord perpendicular, because it has that perpendicular symbol right there. Okay. Then we know that 9x must equal 80 minus x, right? The values of the two arc measures must be equal to each other. They must be congruent. So you have 9x is equal to 80 minus x, and then solving for that, you get 10x equals 80, right? Adding x to both sides of the equation, you get 10x is equal to 80. Divide both sides by 10, and you get x is equal to 8, which does not answer the question because it wants to know what is the arc measure of arc CD. So then you need to substitute 8 for x, right? It's 9x degrees, so 9 times 8 is 72. It is 72 degrees. Okay? And then DE. What is the measure of arc DE? Well, that's pretty easy. The measure of arc DE is also 72 degrees because, like we said, these two arcs are congruent to each other. Okay? And then finally we have, what is the measure of arc CE? Okay? Well, we know that arc CE is equal to arc CD plus arc DE, right? You can add the values of adjacent arc measures, correct? And we know that arc CD is equal to 72, arc DE is equal to 72, so 72 plus 72 equals 144 degrees. So this is 72 degrees here, this is 72 degrees here, and the total is 144 degrees. Make sense? Okay. And then moving right along, in the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay? So if these two chords are equidistant from the center, then they're congruent. So the question is, are these two chords the same distance? Equidistant, right? Equal distance, equally distant. Are these two chords equally distant from the center? All right, well, if we have this chord and this chord, and they meet perpendicular, so they're both, remember the distance from a point perpendicular to a line is the shortest distance. So this must be the shortest distance from E to F. And similarly, this must be the shortest distance from E to G. And if they're congruent, okay, so if they're congruent, if that's congruent to that, that means these two chords are equidistant, and then yes, this chord will equal that chord. Okay? And this looks a little bit strange to me, so here, give me a moment. This should be EF equals E. That's an E, not an F. Okay, that's an E right there. EG. Okay, so AB is congruent to CD. Those two arcs are going to be congruent to each other. Okay, if and only if EF is equal to EG. In other words, this distance is equal to that distance. Okay? So what types of problems might you get there? Well, here it is. This is our last problem, and please copy down this circle and the prompt, and that is hold on, let me go back here. Let me get rid of that. Okay, so given CU is equal to CV is equal to 12 inches. So that's 12 and that's 12. Okay, and ST is equal to 32. So this distance from here to here is equal to 32 inches. Okay? So again, that's 32 inches. Oops. 32. All right. So then the first question is find the given length. So problem 6 is what is the length of QR, and then what is the length of QU, and then what is the radius. Okay? All right, so first off is what is the length of QR? Well, we know that QR is equal to ST, right? Because these two chords are equally distant from the center, right? Because it's given that these two distances are 12 inches. So both of these chords are 12 inches away from the center of the circle. Therefore, they are congruent. So if QR is equal to ST, then QR must equal 32 inches. Okay? So because ST is equal to 32 inches, QR must be equal to 32 inches as well. Okay? And then what is the length of QU? What is this length? What is the length of QU? Well, QU equals 1/2 the whole entire length of the chord. So QU is equal to 1/2 QR. We know that QR is 32 inches, so half of 32 is 16 inches. Okay? And then the next question asks for the radius. What is the radius of the circle? Well, they didn't explicitly draw in a radius. It's okay for you to draw in any necessary parts of a diagram that are missing. So in this case, we want to know the radius. Okay, we want to know that distance. Okay, so what is the radius is our next question. Okay, so what I'm going to do is I'm going to take this circle and I'm going to copy it onto the next page. Okay, again, this is the same circle. There's no difference in the circle. Again, I'm going to copy in this distance. It's going to be the radius. Okay, and that's the radius. And then what I'm going to do is I'm going to take this triangle. Okay, I'm going to take this triangle here, and I'm going to blow it up here so that we could see it a little bit better. Okay, and this is going to translate over here. That's point S. Okay, and then point V, and then we have point C. So this distance here, SC, is still my R. Okay, so that's R. SV, we already figured out from the previous page that that's 16 inches, right? Because it equals QU, which is also 16 inches. Okay, so we know that SV is equal to 16 inches. That's where we get the 16 from. And CV is given as 12. So now we have our two values, and we also know it's a right triangle, so we can use the Pythagorean theorem. Okay, so the Pythagorean theorem states that 12 squared plus 16 squared is equal to r squared, and you can just solve for r and get your answer that way, but just by solving for r. But you can also do it a much more quicker fashion if you notice that this is a triple. So if you notice that 12 is equal to 3 times 4, right? 3 times 4 is 12, and 16 is 4 times 4. Well, the radius is 5 times 4. And then what you would notice is that this is a 3, 4, 5 triangle. Okay? It's a 3, 4, 5 triangle, all with a multiple of 4. Okay? Again, it's a 3, 4, 5 triangle, and therefore the radius is equal to 20 inches. Okay? And again, if you weren't able to discover that this was a Pythagorean triple, you could have just used the Pythagorean theorem. But either way, you should get that the radius is 20 inches. Okay? So that's the end of the lecture. If you have any more Okay, so that's the end of the lecture. As usual, feel perfectly free to contact me at your convenience, and it would always be my pleasure to help you as much as you want, as much as is needed. And also, you can play back this presentation anytime you'd like. Okay, so again, come see me anytime you want, and it'll always be my pleasure to help you. Until then, bye bye.